Hi, have you ever wondered what actually goes on after you hit the power button on your Linux machine? I mean, one moment you're staring at a black screen, and the next your desktop's just there. Between those two moments, lots of things actually happen. So today, I'm gonna walk you through the entire Linux boot process, from the BIOS all the way to the login screen, step by step. Righty, so once you press the power button, electricity flows into the motherboard, waking up the CPU, and the CPU's like, whoa, time to do business, but it's got no operating system yet. No Windows, no Linux, so where does it start? It looks for its first instructions in a special chip on the motherboard called the firmware. This is either the classic BIOS, basic input-output system, or the more modern alternative, UEFI, Unified Extensible Firmware Interface, right? So here's where it gets cool. The firmware kicks off a process called power on self-test or post. This is like the computer's giving itself a quick health check. Yo RAM, you good? CPU, you awake? Keyboard, storage, you there? And if you're unlucky and something's not quite right, let's say the RAM's decided it simply can't be bothered today, you'll hear a set of beeps that sound remarkably passive-aggressive, followed by an error on the screen. That could mean anything from a minor glitch to a full-blown system meltdown. Once the firmware completes its checks and makes sure that all the core components are working properly, it starts searching for a bootable device, and that could be your hard drive, SSD, or even a USB stick with an operating system installed on it, right? So once it finds one, it says, right, my work here is done, peace. And then it passes control to the next layer in the chain, which is the bootloader. And the bootloader is a small program that is stored in the bootable device's initial sectors. But what exactly is a bootable device? Bootable device is basically a storage device your computer can start an operating system from it. It could be a hard drive, SSD, USB stick, or even a DVD, but not a microwave, of course. Wait, so you're saying I can't boot my operating system from a microwave? Ah, brilliant. Cheers for that, mate. What do you take us for? A bunch of bloody lunatics? Calm down, boys. I don't think you guys are crazy. I'm just kidding, man. Let's just carry on. So, now that you guys know what a bootloader is and that it lives inside a bootable device, ready to wake the system up, but not all bootloaders are created equal. In Linux, there's only one name that you'll hear everywhere, which is Grub. The little fella that decides what happens before your Linux system wakes up. Think of it as a waiter at a restaurant politely asking you, which system would you like to boot today, sir? So, in BIOS systems, Grub sits inside the master boot record, MBR, and that's the first 512 bytes of your storage device. It's actually the very first thing your computer reads when it starts. As for the EFI systems, Grub lives in the EFI system partition. It's a small special partition formatted as FAT32, and this partition holds the bootloaders for all installed operating systems. Grub's main job is to hand control over to the Linux kernel, but before it does that, it politely gives you a little menu letting you choose which system or kernel to load, because who doesn't like having options? And you better boot Linux, yeah? Don't use this dog shit. As a matter of fact, I actually edited this video on Windows, but that's the only reason I'm using Linux. That's the only reason I'm using Windows for. Alright, now we're at the heart of Linux, yeah? The kernel. This is the part that talks directly to the hardware. Grub actually loads two main files into memory here. First, there's this one. That's the Linux kernel file. The name might look strange, but it just means virtual memory Linux. It's compressed to save space and it lives in the boot directory. Right, so second one is init-RAM-fs. It's short for initial RAM file system, and that's a small temporary file system that lives in your RAM, and it includes basic drivers and tools that the system needs to get started, especially if your actual disk drivers aren't ready yet. Right, so here's what happens, yeah? Grub loads both the kernel and the initial RAM file system into memory, passes them to the CPU, and then it steps back. The kernel now takes full control of the computer. Right, so now the kernel begins its real work, yeah? First, it detects hardware, USB devices, disk drives, graphics cards, network interfaces, everything. And to communicate with them, it loads drivers, which Linux calls kernel modules. And then it mounts the initial RAM file system as a temporary root file system, kind of a placeholder while preparing the real one. Once the correct drivers are ready, it mounts your actual root file system, usually something like this. Or this. That's where your Linux system really lives. Right, so after the file system is mounted, the kernel runs the very first process in user space. Back in the day, it used to be called init, but today most systems use systemed, and that's the process that brings your system to life. It starts all the background services that Linux need to function, things like networking, sounds, logging, and display managers. At this point, your core services are running and your device is ready, and your system is almost done booting. This is the final step. Once system finishes starting everything, you reach the login screen. If you're using a desktop, you'll see a graphical login manager like GDM or LightDM or SDDM. And then when you enter your username and password, the system authenticates you. Then it launches your desktop environment, maybe GNOME, KDE, KFC, the XFCE, or gives you a shot if you're on a terminal mode. And that, ladies and gentlemen, how your Linux system boots up. If you found this video informative, don't forget to like and subscribe for more tech insights. Peace!